Hi there, my name is Nikola Grcevski and I work on eBPF at Grafana Labs. This presentation is going to be about measuring HTTP response times and meeting SLOs. We're also going to talk a bit about tooling and how some of the tools we currently use may be lying to us and finding other tools that are a bit more accurate. Now we're going to start by building a very simple REST service. It has only one route /ping, responds between half a millisecond to 5 milliseconds. And in this case, we're going to build an application in Go with the OpenTelemetry Traces SDK manual instrumentation, simple as it gets. We're going to drive some load to this application using Work2. But for load generator, really, it doesn't really matter what you use. In this case, it could be even a cloud service like K6. So we have this application built. We've captured a bunch of metrics. And what we're seeing from the output of these metrics generated is what we should expect to see. Average response time about 1.5, 1.25 milliseconds, 99 percentile 4 milliseconds. Seems to match what we expected to see for an application that takes up to 5 milliseconds to respond. Now let's see what Work2 reported in this case. It's quite different and much more different, in fact. We have a 50th percentile that's 100 times more than what we expected from the metrics and what we saw from the metrics. And 99 percentile is 50 times more. And what's going on here? Well, I wasn't being fully upfront about how I generated this workload for this service. I generated a constant load of 500 requests per second on a service configured to only handle about 50 requests per second. So I'm overwhelming the service. And technically, what we measure with the OpenTelemetry SDK in this case is the service time, not the response time. We never measure the time it takes for the request on the queue, the time it takes for it to get served. So really, the measurement starts here. But what happens before? So on a Linux system, what would happen is that when the request ping comes in, a lot of kernel stuff happens. Kernel activity gets sysaccept for exits, TCP RCP establish gets called, and eventually after all those TCP related functions, we get to the Go runtime, which creates a Go routine for us. Now Go routine will eventually have to wait for an M, which is a worker thread, Go speak, and then that worker thread will have to wait for a processor to run up. And eventually we get to run our ping handler. Now, this particular thing we saw, it's not only a Go problem. Most of the web frameworks out there written in various programming languages have the same issue. They have some sort of thread pools. They have queues in which requests wait to be served by those thread pools and so on. Now, fortunately for us, on Linux systems with eBPF, we can actually tap much lower level than our application. So we can tap at the kernel level. We can track functions like TCP, RCP established, or we can track when the Go runtime forks a new Go routine for us to run a particular request. At Grafana, we've built an OSS tool that does auto instrumentation of HTTP and gRPC services with eBPF to do exactly this. So if we use the eBPF on the service we saw before, this is the kind of data we'll get, which matches what we see from Work2. Now the 50th percentile is 130 milliseconds. The 99 percentile is reporting about 250 milliseconds. Same workload, same application, different tool to generate the metrics. Now the timestamp's a bit higher because of how bucketing works with OpenTelemetry. Now if we see a particular trace of this application, one particular request, we see that the majority of the time of this request spent was in queue rather than in processing, which only took about 2.5 milliseconds. So to summarize, collecting accurate production level metrics can be very tricky sometimes. We just saw an application that, when overwhelmed, failed to correctly report that it's being overwhelmed and that actually response times are pretty bad. With low-level instrumentation tools like eBPF, we can get much better outcomes because we can measure things outside of the scope of the application. And finally, thank you for watching this presentation. Our project is open source. Feedback and pull requests are always welcome. You can also find us on the Grafana Lab community Slack at the channel eBPF.